Now we're looking at chapters 4, 5, and 6. So I'm following along with the final exam review. So you'll notice the first concept under the chapters 4, 5, and 6 are vector problems. So there are 2 examples of vector problems in the final exam review, so I was going to work through those. So with vector problems, you have 4 possible equations to choose from. So what you need to figure out is the information given, what is it? I realized I forgot this 20 degrees here, so that you can figure out the other 2 variables. Okay, so in this case we have an airplane flying 200 miles in a direction 20 degrees north of east. How far north and how far east? Okay, so remember, north is the y direction. East is the x direction. So if we draw our axis, right, this is the x-axis, this is the y-axis. So y is equal to north, x is equal to east. So right away I can tell that it wants me to solve for my x and y components. Okay, so what are the other 2 pieces of information? Well, when it comes to vector problems, the only variables we have are x, y, a, and theta. So we already figured out what our x and y are. Now we need to figure out what a and theta are. And theta is always an angle, a degrees. So that tells me that this 20 degrees must be my theta. So by default, that 200 miles, that's going to be my a. I can draw a quick picture of this as well. So the airplane's starting at the origin and it's traveling 200 miles. That's my a. The angle, my theta, is this angle right here, and that's going to be 20 degrees. So what it's asking me to solve for is the x distance. So if I follow this down, what is this distance here? And then my y distance. So this distance here. So since x and y are what I'm trying to solve for, I'm going to pick the equations where x is equal to and y is equal to. If you look at those equations, for x it's a cosine theta, and for y it's a sine theta. Now the important thing when you're doing these vector problems is that your calculator is in degrees, not radians, or it will give you the incorrect answer even if you are putting it incorrectly. If you are putting it incorrectly, that sounds funny. Okay, so a, that's my 200 we just said, right? So this becomes 200 cosine, and then my theta was that 20 degrees. For the y, it's going to be the same thing except for sine 20. Make sure my calculator's in degrees. It is. So 200 cosine 20. And I get 188. Now the nice thing about these vector problems is you don't have to convert. So notice we're in miles, and for a lot of our physics problems, we want to be in meters. So that would require a conversion. Vector problems are nice because you just keep it in the units it's in. So if it gave me miles in the question, miles are the units on my answer. So it's saying 188 miles east, or in the x direction. So that's this distance here. For the bottom one, we do 200 sine 20. So for the northerly direction, we get 68 miles north. So that would be this direction here. All right, so this is one of the possible choices that you'll see where you're given a and theta, and you solve for x and y. There's another version, and that's what we're going to see in this helicopter example. So here we have a helicopter flying 45 miles east, 20 miles north. How far from the starting and in what direction? Okay, so we're using our knowledge and applying it. So 45 miles east. So is east going to be my x, my y, my a, or my theta? That's my x. That's the x-axis going east. Okay, 20 miles north. So I've used x, so that 20 miles is either going to be y, a, or theta. And since it said the word north, that tells me this is my y. How far from the starting point and in what direction? Okay, so if you ever see what direction, that's always my theta, right? In this question here, it said in a direction of 20 degrees. So the direction is your theta. So it wants us to solve for theta, and then how far from the starting point, that's my A, right? I start at my origin, how far did I get? Okay, so X is 45 miles, Y is 20 miles, and then A and theta is what I'm looking for. So this time I'm going to pick the equations where A is equal to and where theta is equal to. So for A, we're taking x squared plus y squared, the square root of that. For theta, we're going to do second tangent, and then it's y over x. So let's plug in. So I'm going to take the square root of my x is 45, so 45 squared plus 20 squared. For my theta, I'm going to do the second tangent button on my calculator, and then I'm going to enter my y first, so 20, and then divide it by 45. I get 49 for my A, and that's how far from the starting point, so that's going to be miles because my other two distances were in miles. And then what is the angle? What's my theta? What direction? So second tangent, and I get 20 divided by 45. So the angle is going to be 20, I'm going to round up to 24 degrees. Okay, so those are the two types of vector problems that you might encounter on the exam. So let's go to the second concept, non-zero velocity and zero velocity problems. So these are word problems. They're going to take me a minute here to write, so I have some problems here. So let's start with a dog. We have a dog initially at rest, laying down in the sun, sees a squirrel, and chases after it. So that's what dogs do, right? Reaching 7.2 meters per second in 1.8 seconds. Oops. We are going to calculate the acceleration. So these types of problems, zero initial velocity and non-zero initial velocity, is important to do our list, right? Convert if necessary, make the list, and then we'll pick, because there's so many different equations to pick from. It's important to know what we have and what we're looking for. So we have a value of 7.2 meters per second, so we need to label that with the correct variable. The units meters per second tell me that that's v, a velocity, and we do want it in meters per second. You always want to check the units. If it was in miles per hour, we would have to convert it. The next piece of information, 1.8 seconds, is what? It's going to be a time. Okay, so moving through this, we need to calculate the acceleration. Well, to narrow it down further, am I using zero initial velocity or non-zero? So I'm looking for clues in the word problem. It tells me the dog is initially at rest. So that means that it is going to be zero initial velocity because it was initially not moving. So that narrows down my equations at least. So to calculate acceleration, one of the equations I can choose, there's multiple to choose from, but this is going to be the easiest for me because I don't have to rearrange it. So to figure out acceleration, you're taking velocity and dividing it by time. So I'm going to take that 7.2 meters per second. I'm going to divide it by 1.8 seconds. And the acceleration of the dog was 4.0 meters per second squared. So acceleration is meters per second squared. look at a few others. I'm going to have a rock being dropped from a bridge, and it hits the water, H2O being water, 1.3 seconds later. We are going to calculate height of the bridge. All right, so let's start with my variables. I have a rock being dropped from a bridge, hitting the water. Looks like 1.3 seconds is the only piece of information given to me. So seconds is a time. I'm going to write that as variable t. It wants me to calculate the height of the bridge, so that's going to be either an h or a d, because height and distance are the same thing, just depends upon the equation we're using. Now this doesn't seem like enough information to solve the problem, so there's something else I need to recognize from this word problem, and that is that the rock was dropped. So remember, if anything's dropped or falls or jumps from a height, a distance, that's free fall problem. Okay, so with free fall problems, we have another piece of information not explicitly given to us. And that piece of information is gravity. Because if something's falling, gravity is affecting it. And gravity is our A values in those equations. It's the acceleration, the rate of acceleration. And on Earth, that's going to be 9.8 meters per second squared. Excuse me. So now we have three variables, so we need to find an equation that has A, D, and T in it. The equation I find is this guy here. Distance is what it's asking for. I have my acceleration, the rate of gravity since it's free fall, and I have my time. So, plugging in those values, I can see what the height of the bridge was. And the bridge was 0.3 meters. Not too terribly tall. All right, so that covers non-zero velocity problems, zero velocity problems, and free fall problems. So looking at bullet point 4, be able to use force equations. Okay, so be able to calculate weight force, which there's a problem in the practice final to calculate weight. Remember, that's similar to free fall because you're using gravity in that calculation. Also be able to calculate linear force. So if I have a 3.5 kilogram ball and it's kicked with 7.1 Newton force, let's calculate the acceleration. Because there will be some rearranging of equations on the final. Not a lot, but some. So you still need to know how to rearrange. So let's make our list. We have 3.5 kilograms. So what is that value? It's a mass. We want it in kilograms. Remember, all physics masses should be in kilograms. 7.1 Newton force. It tells us in the sentence that that is a force. And then it wants us to calculate acceleration. So looking for force equations, you just need to know how to do weight force and linear force. So you don't have to worry about the gravitational force, you don't have to worry about centripetal force. Okay, so you can ignore those questions when you're reviewing past exams. Focus on linear and weight force questions. So F is equal to ma is our linear force equation. And in this case, we're solving for A. So we do have to rearrange. So I want A by itself. So I'm going to divide both sides by m. I get acceleration is equal to force divided by mass. So I can plug in my values, 7.1 going on the top and my 3.5 going on the bottom. And I get 2 sig figs, so 2.0. Remember, acceleration is meters per second squared. So that's the acceleration of that ball given that amount of force. So be able to calculate work, kinetic energy, and potential energy. So review problems involving any of those 3 types of energy. There's some on the practice exam, and also review old exams with those types of problems. I'm going to do one type where we are going to calculate the potential energy of a glass a 0.55 kilogram glass on a counter. So remember when we were talking about potential energy, that's the stored energy. Okay, so it's an object not moving. It's potential. How much energy could it have if it fell? Okay, so this glass is just sitting on the counter. It's not actually moving, but it does have potential energy based off of the height that it's at. So this first piece of information, my 0.55 kilograms, that's going to be my mass. The 2.2 meters high, so that's a height or a distance, same thing. And potential energy is what I'm solving for. The nice thing with these equations is, unlike the zero initial velocity equations, you only have one equation for potential energy. And that is mgh. So mass, I have. Height or distance, that h, I have. But what is g? It's gravity. I do have that. It didn't give it to me specifically, but I know what the rate of gravity is. So I can write that down and plug it into my equation. So let's figure out how much potential energy that glass has. Because once that glass falls, that potential energy is going to change into kinetic energy, which is moving energy. But while it's not moving, it's just potential. So the potential energy of that glass is 12, and all forms of energy, joules. Whether it be kinetic energy or work energy, any type at all. Calculating power, I would review some problems like that as well. Be able to convert, and we talked about conversions. I did some examples in chapter 1, conversions. So just review those types of conversions. Terms to know, so I have a list of terms and definitions you might want to review. Also, Newton's 3 laws of motion. Know those. Have your notes ready for those. Okay, you will need to be able to tell me what law I'm talking about if I describe any of Newton's 3 laws. So the first law, law of inertia. Second law, which gives us the equation force is equal to mass times acceleration. The third law, know that one as well. Sorry, it's hard for me to talk and write at the same time. For a reaction, there's an equal and opposite reaction. Sorry, that was the third law. Just want to do one more calculation with momentum. So, calculate the momentum of a 950 kilogram moped traveling at 12 meters per second. Okay, so you're not going to have to calculate impulse, which is the change in momentum on this exam, but you do need to be able to calculate momentum still. So remembering momentum is represented by that letter P. Okay, and it's equal to mass times velocity. So it depends upon the object's mass and on how fast the object is going. If the object's not moving, its velocity is 0 and it has 0 momentum. But in this case, that 950 kilogram moped is moving, so it will have a momentum. It's moving at 12 meters per second. So you simply multiply those two numbers together. to figure out what its momentum is. And the reason I have it at 11,000 is I'm trying to keep with 2 sig figs. Units on it are kilograms for mass times meters per second for velocity. All right, so this sums up what you need to know for chapters 4, 5, and 6. So review these bullet points on the final exam review and make sure that you're doing that practice exam with similar problems.